Hello everyone, I am Shashikiran, working as an assistant professor in Electronics and Communication Engineering, Nagarjuna College of Engineering and Technology. Electronics and communication is not only a branch, it is an opportunity to solve the real world problems. And now, in these videos, I will be discussing about the control systems concepts and how these concepts can be effectively applied in the real world computations. Hello everyone. In this video, we will be discussing about the Routh'S stability criterion. Basically, the Routh'S stability criterion is used to find the stability of the system. And how we are going to find the stability in this technique is in the characteristic equation. Just we will take the coefficients of that characteristic equation and we will arrange those coefficients in the form of an array. So by taking in the form of an array, we can find the stability of the system. So first, as an example, here first I will consider with the general form of an characteristic equation. So the characteristic equation will be in the form of one coefficient. I will treat it as a naught into s power n, where the n represents the maximum order of the characteristic equation, plus similarly continues the a1 into s power n minus 1. The continuously the order of s is going to decrease. So a2 into s power n minus 2 till continues at the end is equal to 0. This equation represents the general form of the characteristic equation. Now I will give one value, one numerical value to the n, so that we will get a clear numerical equation. So if I take the value of n as 5, so if I take the value of n as 5, so the characteristic equation will become a naught into s power n s power 5 plus a1 into s power 4 plus a2 into s cube plus a3 into s square plus a4 into s power 1 plus a5. After a5, s power 0 will be considered as 1 is equal to 0. This is the characteristic equation which I am taking to solve the stability using the Routh'S stability criterion. Now, in the Routh'S stability criterion, actually we will consider with the table where the first we will take with the s. So s order will be taken in the decreasing order. So s power 5, s power 4, s cube, s square, s power 1. So this will be the order which I am taking out here. So after taking this, already told, we will arrange the coefficients of the characteristic equation in the form of an array. So in this matrix, in this table, the first two rows represents the coefficients of the characteristic equation. So now in the first row, the first place, first bit what I am taking is the first coefficient what I have, that is a0. So a0 is the first coefficient in the characteristic equation, and next what I have is a1. So that I will consider in the second row. So second row. Alternatively, we will take with the coefficients. So first I have taken the a0. The first row will be alternative coefficients. So a0, a2 and a4 all will come in the first row, and a1, a3 as well as a5 will come in the second row. So after a0, the alternative coefficient what I have is a2 will be in the first row, and next the alternative coefficient is a4 that will come in the first row. Similarly, in the second row, the first what I got is a1. After that, the alternative coefficient that will be a3 and a5. So like this, I have taken the coefficients of the characteristic equation in the first two rows. So after taking this, I have to continue with the further steps. So what we are going to do is, just I will consider this value as b1. So how I am going to calculate the b1 is, the b1 is equal to, so just I will consider this as a matrix. So first I will multiply these two, down to upwards, by in minus upward to downwards. By multiplying these two, I am taking, so b1 will be what? a0, a1 into a2 minus a0 into a3. a0 into a3 I am taking out. So divided by, in the second row, whatever the first term I have, that will be taken in the denominator. That will be A1. So this is the formula to calculate the term B1. So similarly, suppose if I have a B2 here, so how we will calculate that B2 is, B2 will be, so I will take B2 here. So now how we can calculate the B2 is, so again, always the first column will be constant. Every time we have to consider that, and after that whatever the term we are calculating, the next column whatever I have, the previous rows, that I am considering. Now the B2, how I am going to calculate is, A1 is multiplied to A4 minus A0 is multiplied to A5. So how I will get, B2 will be A1 multiplied to A0 is multiplied to A. Divided by, again, the first term whatever I have in the previous row, that will be a denominator, that is A1. So like that I have calculated with the B2 also. So similarly, if I have a B3, so how we will calculate the B3 is, again, so after this A4 and A5, I don't have any of the terms here to multiply. So what is the rules? If I am finding this term, so the first column, and after whatever the term we are finding, the next column we have to multiply. So A1 is multiplied to this term, but here actually I have 0. So A1 is multiplied to this 0, 0, and here even we have multiplied, this value will be 0. So we will not get any of the term at B3. So that is, so next, for the simplification, in the next column, so what I will get is the C1. So how we will calculate the C1? So the C1 will be, the C1 is given by the same, again, whatever the term you are calculating, for that, we just the previous two rows we have to consider. So for C1, the B1 is multiplied to A3 minus